Hello, grade 7. Today's lesson is about areas of triangles. First thing first, there are several types of triangles. There's right angle triangles, isosceles triangle, and so on. However, whenever we talk about triangle, we all know that the first word tri in Latin, that means three. So triangle is fancy way of saying I have three angles. So angle type basically determine what type of a triangle that is. So for instance, when I mention about right angle triangle, this 90-degree is my right angle. So that's why I have perpendicular angle on this side. So if this is an example A, B, C, I have another angle A and another angle C. So you do know that there are three types of angle. This is the reason why triangle is always having a three-sided area. Before we begin, we need to understand where the triangles come from. It actually comes from two different type of two-dimensional shape. As you may know, one is known as a square, one is known as rectangle. First of all, you may not know the difference between square and rectangle. You should know, however, square is an easy way of saying if I have four sides that is identical. That is what we define as square. One big thing that we need to understand is addition of all of the angle inside of the square make 360. So if you rather think about it this way, 360 divided by 4, that becomes 90 degrees. So perpendicular sign for every single situation. Rectangle on the other hand have two pair of identical sides. So you may see that I have left and right identical to each other, up and down identical to each other. Angle, same as square, 90, 90, 90, and 90. So how do we know the area of a triangle? How can we find the triangle out of this square and rectangle? Why Mr. Kim bothered bring this out? It's because in fact, let's think about it this way. A, B, C, D, same thing, A prime, just little differentiation, C, D. In ancient Greece and Egypt, people think about agriculture situation. You have a land, but the thing is, we needed to divide the land into multiple different ways. One of the easy way is halfway, and then make this square into two different rectangle or rectangle into two different squares. Something like that can happen. However, the one of the other way that people also found was basically cutting in half like this, diagonally. And they found that, what do you know? The area that I have in here is exactly identical to each other. Same thing occurs when you look at rectangle too. If I cut these guys diagonally, area that I have, ABC, is completely identical to the other one. So geometry actually came from agriculture. And people decided to share some of the land, what would be the good way of sharing, those kind of things. So it's actually landscaping situation. So if you actually look at the area calculation, width, length, we all know that the square area is width times length. Same thing happened for rectangle too. When you talk about area of triangle, basically only thing that you need to do is divide this product of area by 2. This is your area of the triangle. Width times length divided by 2. In some Canadian curriculum, for example, your MathLink 7 textbook, area, I believe, it used base times height over 2. Don't worry too much about it. Base is like horizontal distance, width. Height is like vertical one, length. And divided by 2, it means exact same thing. So when you talk about triangle, let's think about multiple different types. What can be base and height, width, length? How can we know? So as you may see, I draw 3 different types of a triangle. Triangle number 1 has 1, 2, 3 sides that is completely identical. Triangle number 2 has right angle, which is perpendicular angle over here. And triangle number 3, which is known as isosceles triangle, where 2 of the sides completely share the same angle and length, something like that. There are numerous types of triangle that you will see, ladies and gentlemen. One thing that you need to understand is always the bottom part, which base or width, is always, I like to say, horizontal measurement. When it comes to vertical measurement, number 2 type is a little easy. Height is always perpendicular, or I like to say length, always perpendicular to the base. It's always have to be 90 degrees to each other. Then you may understand a little bit of dilemma in here. When you look at first triangle and second triangle, there is no concept of perpendicular angle. There's no 90 degree, there is no 90 degree going on in this situation. So what should I do? Well, this is the reason why you're using your ruler, and from the maximum height over here, just create perpendicular measurement, because that becomes your height or length in this situation, ladies and gentlemen. You can create this perpendicular angle and vertically reach to the maximum height of your triangle. That becomes your height or length. Same thing happened if I look at isosceles triangle. This dotted line that I draw is the one where length or height, what I like to put. This is something that you may want to happen in your mind. Very similar situation as parallelogram. I like to say this slanted side over here is not your height. Same thing for isosceles triangle. So whenever people talk about height or length, that's always 90 degree to your base or width. Let's do some example. Ladies and gentlemen, please pause this video if you need to and copy this diagram. Once you copy this, I'm going to explain. So, I have a triangle over here. I have 10 centimeter, 9, 7, 12. I have a lot of measurement. What should I do? Well, basically your first job is finding out what is my base and what is my height. Again, if you want to go width, length, feel free. I use either way. This question I'm going to use base and height. The next one I'm going to use W and L. In any case, the easiest way that you can find base and height is locating this 90 degree right angle triangle, because based on that 90 degree perspective, horizontal length will be my 10 centimeter. That becomes your base, ladies and gentlemen. On the other hand, height, which is my vertical distance from that 90 degree, is my length situation. Then some people may wonder, Mr. Ken, what happened to my 9 centimeter and 12 centimeter? We do not have to use these two. Only thing that we need is horizontal distance, vertical distance, that make 90 degree. So we're basically using this. That's my step number 1. Step number 2 is basically your formula. Base times height over 2, which is base is 10 centimeter, don't forget the unit all the time, times by 7 centimeter divided by 2. That's my second step. I like to say formula and substitution. My third step is now calculator time. Basically 7 times 10, that's 70 centimeters square, divided by 2. If you use your calculator, that becomes 35 cubic centimeter. This may require rounding scale, depends on what type of question that you're doing, but it does involve these 3 steps. Okay, the next example is a bit of an advanced question. I'm using the textbook, Math Link 7, page 112, example number 3. As you may notice in this diagram, there is a funky type of a triangle. What I need to do from that question is, I need to find the area that I shaded over here. But something that you may notice is, I have obtuse angle over here. There is no concept of 90 degree. Whenever that happens, you need to basically extend the line of the base and find out the vertical height. So, of course, this diagram is given in your questions. However, what I did is, I know the base. This is my base. Or, like I mentioned, I'm going to use the word W, width in this case. My job is finding out the length. However, this is not my length because of one reason. It's slanted height. Slanted height cannot be equal to height, or it cannot equal to my length in my formula. It has to be 90 degree. Now what you need to do is basically again extend the line and find out my 90 degree right angle, and that 1940 become my width. I'm sorry, my length in that situation. So first step is done, finding out what clue. Second step, area is equal to base times height over 2, in this case length times width over 2. Thus now we are substituting the whole thing. Area is equal to 370 meter times by 1940 meter divided by 2. And once you do everything, I'm just going to give you a final answer. Your final answer should be 358,900 meters square. It's a huge number, but it's okay. It was one of the realistic example situation. In real life, if you see meter square, something like that, you don't want to use that kind of gigantic number all the time. We sometimes use hectare, acre, those kind of conventional area unit, which you will learn in high school more.